Hi and welcome. AI is here, there, and everywhere, it seems, which is great, but I'd like to focus on one practical application that we have developed that can be applied today. My name is Simon Green, and I'm a Principal Technical Specialist at Avineon Tensing in the UK. Avineon Tensing are a partner of Safe Software and also Esri, and we've been building out transformers and workflows for the Esri Data Interoperability extension to reach a range of different AI services, including locally run ones, for some time now. Now, we all know that rich metadata is the foundation of trust and transparency, yet it remains one of the most difficult things to maintain at scale. So in this presentation, I'm going to show you how we can bridge that gap. We'll explore how to use the Esri Data Interoperability extension as a no-code orchestration engine to automate metadata generation using AI. We'll specifically look at how embeddings allow us to move past simple keyword searches to a future where we can search for assets using natural language and semantic meaning. So by the end of the session, you'll see how these tools remove the traditional barriers to creating high quality metadata, making your data more discoverable and your organization more efficient. Now, I think we all know the problem. The screenshot in the bottom right-hand corner of the slide may feel familiar to some. We might have incomplete metadata. It could be missing entirely or just inconsistently applied across our data sets. Now, if we're being honest with ourselves, fixing it is likely to be at the bottom of our to-do lists. And that neglection is because historically it's been time-consuming and tedious. Now, whilst basic metadata like bounding box, data format, coordinate system, and such like are easy to create using some basic tooling, it's the more nuanced things like keywords, titles, descriptions that prove a little more tricky and time-consuming to create. So the impact then, as the AI-generated image of my colleague Siobhan shows, is I don't think we can underestimate the impact of poor metadata. Finding data becomes much harder, and if the data is not being used because we can't find it, it's perceived to be of no value. So an organization could be sitting on data that they don't know exists. And what if we actually find the data? Then can we be sure that it's suitable for what we want to use it for? So you may have heard about the great new item details assistant that is currently in beta for ArcGIS Online. Our solution is a little like this, except it's available today. It can process all feature services in bulk, and it works for feature services in ArcGIS Online and also Portal. And in fact, actually, the process can be applied to any data source you like. And it reviews attribute content, not just schema, and has a human in the loop element for approval and peace of mind. Now, it's important to point out that this is not a black box. This is a technical solution that we help to integrate and set up for your environment, mentor you in how to use it, so it evolves with you as your data does. Now, I remember when I was at school a long time ago now, sitting exams, and that blank piece of paper at the start of the exam sometimes felt a little bit, hard and a bit overwhelming and a bit daunting. And I kind of feel like metadata can be a bit like that for organizations. So with this solution, we want to change that for organizations, make it less overwhelming and give you something to review instead of having to start with that metaphorical blank piece of paper and do this all manually. So how does this work? Well, the tool that orchestrates this whole process is the Data Interoperability extension in ArcGIS Pro. And that uses something called a workspace. Now, for people that are not familiar with the interoperability extension, it's essentially an orchestration tool and a traditional extract, transform, and load. So this workspace defines a process which extracts and discovers your feature services. It analyzes the schema of those feature services, and it builds context by getting information from that schema and compiling statistical data on the data itself inside of that feature service. And that helps inform and gives it context and generates then metadata suggestions using AI. Now, this process is dynamic, it's schema agnostic, and it adapts to any data structure that it encounters. And for that sort of peace of mind, we've got this sort of human in the loop baked into the process to allow you to approve any updates before committing them. Now, if you already have metadata, then that's great. This tool can also be of benefit to you because it can help standardize, augment, and potentially restructure your existing metadata. Now, the metadata might need to be structured into a particular specification required for your business needs. The tool can do that for you. And that could be Inspire, UK Gemini, or another ISO standard of metadata creation. And also, as I mentioned, we go deeper than just analyzing the schema. We look at the data in those services too. And this obviously provides more context for the generation of not only service level metadata, but field level metadata as well, as we shall see shortly. And on screen there, you can see an example of the sort of the tabular output before it's written out to a neutral format like Excel spreadsheet that can then be reviewed and revised by a human pair of eyes. Now, the second workspace takes this scrutinized, moderated output from workspace 1 and importantly only applies the approved metadata updates to the appropriate ArcGIS feature services. And when this is completed, a summary report is generated, which gives you then an audit trail of what has changed and when. And just to focus a little bit on some of the transformers that are used inside of that workspace, I'm not going to show you a full workspace. It can be quite overwhelming and lacks a little bit of detail on a screen. So I'm just going to pick out one of the key transformers that is available in the Data Interoperability extension, and that's the ArcGIS Online connector. So basically, we're able to configure this transformer to update the details of a feature service with the moderated output from the previous workspace. So you can see there we've got references to tags, to summaries, to descriptions, and to the bounding extent of the data itself. And you can use this to update your metadata using this connector in the interoperability tool. And what does that look like when the process has been run? Well, we have now on the right-hand side service level metadata. So that is descriptions, it's summaries, the tags are generated for the entire feature service. And remember that AI service is using the contextual information derived from the feature services and the data that is contained within to create this compelling and informative metadata that accurately reflects the service's purpose and content. And perhaps more interestingly, we also have got this field level metadata generated as well. So this includes generating aliases and descriptions for individual fields within the feature service. So the AI leverages that schema information and statistical summaries to create user-friendly aliases, detailed descriptions that explain the meaning and the purpose of each field, which you can see highlighted in the orange boxes there. So Just to sort of round up the metadata creation then, if you like, this is really great if you have no metadata at all. It takes away a lot of that manual effort of gathering lots of pieces of information from potentially many different people across your organization and manually curating that and entering it into a system. And if you already have metadata, then you can use this tool to make it richer and more consistent, or standardize it, or even restructure it. So remember, this solution evolves with you as your data does. So it can be run multiple times to gradually refine and augment new information and data as it comes to light. So now we have some metadata. Let's make it discoverable with semantic search. Now, historically, this has been quite hard, with many data portals being reliant on keywords to find data. So let's look at an example site. So this is the Stream Water Data Portal. It's no different. Stream is an open data initiative between UK water companies and industry and civil partners to unlock the potential of water data. And, we're using a simple keyword search to return some results. But, we've probably always already been here as well. So a simple typo reducing our search to nothing. It doesn't have to be like this. And what I want to show you at the end of this presentation is that we no longer have to be limited to keyword style searches. Now, to understand where we're going, we have to look at where we've been. So this is sort of a very brief history and evolution of search. So things started out with the like syntax inside of things like SQL for really basic pattern matching. So if you search for something like happy, you're not going to find happily. Okay, now it evolved somewhat with the introduction of full text search, which came to databases like Postgres, SQL around 2008, and added this sort of fuzzy matching. So something like Apple, if you spelt it wrong with APLE, would find APPLE for the correct spelling of Apple. But here, and now semantic search is a real game changer. So it doesn't care about the spelling, it cares about the essence and the meaning. So it understands that perhaps reservoir and water storage are related concepts. And the secret sauce of semantic search is the embedding. So the embedding is the process of turning unstructured data like metadata descriptions and other things that we might have created inside of our ArcGIS feature services for the metadata into a numerical representation of meaning. So we take the content we are going to pass into our model, and it will give us a vector that numerically represents that content. So to a computer, these numbers represent a machine-readable coordinate of that text's meaning, which means we can do things like similarity comparisons and other neat things. Now, if vector sounds a little bit intimidating, don't panic. As kind of GIS professionals, we've been doing this for decades through geocoding, right? We turn an address into a lat and long. We are essentially creating a 2D vector of that address. Now, embeddings are just geocoding for meaning. Now, instead of 2 dimensions, we are actually working in 512, 1024, 2048 dimensions. Now that is quite hard to conceptualize, but the golden rule here is that distance equals similarity. So the closer two vectors are in this multi-dimensional space, the more similar they are. So on this map of meaning, two items that are closer together are semantically related. Now, historically, it's been difficult to find what you want in open data portals, as we've discovered, as this sort of traditional search functionality lacks the context and the intent. And as we saw, the stream data portal sort of typifies that and only really allows keyword type searches. So a more natural language-led approach to search can help generate more meaningful results, and a combination of embeddings and data interop can facilitate that, as we shall see. And so, metadata and the creation and the process that we've just explained previously would be a good application for embeddings. And if you've invested in it and you've worked hard to create the metadata, kind of makes sense to be able to find what you're looking for. And part of this technical solution that I'm going to talk about now will utilize something called FME Flow, which is a sort of a cousin, if you like, of the data interoperability tool, and is an enterprise data orchestration tool set. So how does this process work, and how do we create these embeddings? Well, we're using the data interop tool to do this, and we're going to scrape and read a list of feature services and retrieve all that good metadata that we have created in the previous talk, and we're going to take that and use it as the input into the creation of the embedding. And that embedding will get generated in Azure Foundry, in this case, using a text embedding model. And the JSON output from that, so we're communicating via the API to make these calls to create these embeddings. The JSON output needs to be restructured and cleaned slightly to then be put into an Azure SQL database. Now, it doesn't have to be Azure SQL. It could be a regular SQL Server or a Postgres database, essentially a database that can serve and store vector data. So this process, this workspace, is actually really quick to run. And you could schedule to regenerate the embeddings as and when your feature services change. So be it, the content of the feature service, whether there's more layers or more data in there. And actually, the embeddings database itself is really quite small. So in this instance, for 205 approximately feature services that were scraped and embeddings created for, the size of the database table was less than 3 megabytes. Now, of course, there are other embedding models available, not only through Microsoft Foundry, but Azure, OpenAI, Deep Infra, and other platforms that can be utilized inside the data interop tool. And really, the data interoperability tool doesn't really care what platform it is. If there's an API, it can connect to it. And models can also be run locally using Llama as well. So nothing actually ever needs to leave your environment, which can obviously help to keep IT on side. And as I mentioned, these embeddings can be stored in a database that supports vector storage, so Azure SQL, SQL Server, or Postgres. Now, we have created a dynamic data catalog inside of hub.arcgis.com in our own site. And when I navigate to that URL, to hub-avineon-tensing-uk.hub.arcgis.com, this triggers a workspace to build the data catalog web page and stream it into the iframe that we have embedded in that hub page. So this web page is created at runtime, and so will always be built using the most up-to-date information. And it does this through the use of a webhook trigger that's sat waiting for you to click on that URL to then trigger FME Flow to run that workspace and generate that web page. So what we get is, on the right-hand side there, our data catalog page, which is our user interface to allow us to then search. So when we do actually click search after entering our term, our search term will get sent again to a webhook, which triggers the running of a workspace, which takes that search term, turns it into an embedding, and then queries, really importantly here, the database of embeddings. And the results essentially get streamed straight back into the data catalog page as JSON. Now, the important thing to remember here is that when we're generating embeddings and we are searching and doing similarity queries in our database, we need to make sure that the embedding model that we use for the creation of the initial embeddings and also for the search term here, we're using the same model. So again, in this case, we're using AI Foundry and one of their text embedding models. Now, these embedding models work with many different languages too. So I can actually search in that portal in a different language and it will still return me relevant results. And the key thing here is that FME Flow is orchestrating the whole process behind the scenes. So the workspace that was created in data interoperability, so the workflow that you see on screen now, is created in data interoperability tool, is published to FME Flow, which is then run to process the search term, generate the embedding for that search term, and then query the embedding database for similar vectors, and streams that result back to us for an instant display in the data catalog. Now, although this is built inside an iframe in AGOL Hub, you could equally create a custom widget in ArcGIS Portal to allow you to perform semantic search. So let's look at a demo. I'm going to just click on the page there to open up the search portal. Okay, and we can see here we've got that that data portal that allows us to search for some terms. So I'm interested in finding out about water storage. So this is the data water portal data sets. So these are all the feature services. And I can hit search and you can see there that we get a lot of returns around reservoirs and water storage feature services across different water utility companies in England and Wales. So that's great. Okay, now I can also perform that same search in an entirely different language. So maybe I want to try a bit of German here. So I can hit search, goes off, queries the embeddings for similarity, and comes back again with water storage, feature services, and reservoirs there as well. Okay, so this I think is a bit of a game changer. And there are no real barriers to do this tomorrow with your data or even today if you've got the data interoperability extension or perhaps FME. Now, most people these days have probably got access to a database such as SQL Server or Postgres. And with the flexibility with the embeddings models, you can have it locally or use one of the many cloud services available. But I think the upshot of this technology is that it opens doors and makes content more accessible through smarter search. Quick wins, minimal efforts. And, both of these technical solutions that I've talked about in this presentation are something that we can provide right now. And if you're interested in talking to us about either of them, then please speak to us. Now, thank you very much for watching. On the screen there, you can see a couple of QR codes, one to the Stream Water Data Search demo and one to our technical solutions page. And I'm just going to flick the presentation onto the last slide where we have contact details. Thank you again for your time, and look forward to speaking to you about these wonderful technical solutions soon. Thank you very much.